So in this section, we're going to look at scheduling resources, and we're going to break it into a couple of bits. We're going to look at scheduling, critical path and critical chain. We're going to look at resource management, and we're going to look at cost planning and earned value. So we're really getting down to the nitty-gritty bit of the detailed planning of projects here. So what's a schedule? What do we mean by scheduling projects? So remember we talked about the work breakdown structure. That identified all the work required to create the project, and identified there were different people involved. So I talked about some work packages may be contractors, some work packages may be agency staff. And I want you to ask the question, are you ever waiting for something off from another person before you can do your work? And those dependencies are what we're trying to understand. So what precedes your work? What are the predecessors before you can do your work? So the first step is to develop that precedence diagram. So before 1.3.1 person can get on with their work, they need information from two other people, 1.1.3 and 1.2.2. So when those two people have finished their work, I can get on with what I'm doing, but I can't start because they precede me. So what we need to do is understand those precedences, and we express those in a precedence diagram. Now we can build these up with a couple of different types of link. The simplest is a finish start. When we've finished building the foundations, we can build the walls. When we've finished the roof, when we finish the walls, we can put the roof on. When you've got the report, you can then issue it. So one thing's finished, something else can start. There's a couple of other more varied links that we can have in our projects. We can have a start. So when one task can start when another task starts, often with a lag. So if you're putting clay pipes in a trench, when can you put the first pipe in the trench? Well, you can't do that till you've started digging the trench. And you might want to lag, so 3 days after you've started digging that 10-kilometre trench, you'll start the pipe laying. When can you finish? Well, that's a finish relationship. When can you put the last pipe in the trench? Well, you can't put the last pipe in the trench until you finish the digging. So the finish of the pipe laying is dependent upon finish digging the trench. So when is this used? This is often used for quality assurance or safety case or design files. So when do we start the design record? At the beginning of the design phase. When do we finish it? Well, it can only be closed out when all the design documentation is completed. So if the design takes longer, then that assurance role will take longer. So that leads us into the concept of early start and late start. So why we're doing this is we're trying to understand how much float there is on each activity. So I'd like you to think about when you're at school, if the teacher gave you some homework and they gave it to you on a Monday and said I want it back next Monday. How much, say it's an hour's work, when was the earliest you could do that homework? Well, you could do that homework on a 3:30 on Monday evening and you'd have it finished by 4:30 Monday evening. So that'd be an early start, early finish. When's your latest start? Well, it's got to be in Monday morning at 9 o'clock. The latest is maybe 8 o'clock Monday morning. Get up, do it on the bus on the way to work. So the advantages about doing the work early, get out of the way, get on. The advantages, some, of doing it late. If there's a change, you're not sinking resources into something that might change later. The difference between the earliest and the latest you could do your homework is what we call float. So in my example, it's probably 6.5 days, from Monday evening to the following Monday morning. And that's the amount of time you can put your homework down and not do it, but still complete your objective. Now in a project, some things have float and some things don't have float. So from here we can develop the precedence diagram, understand how much float each of the tasks have. So here's a simple plan with two paths, a top path, a bottom path. The durations are shown in weeks. So how long is it going to take to do this project? Well, the longest path is the top path. Add up the durations on that top path, you're going to get 11 weeks. So the critical path is going to be the top path. So how much float are we going to have on the bottom path? So if you compare the top two activities, that's going to take us 6 weeks to do that work. Compare that to the bottom two, they're only 3 weeks. So those bottom two activities are going to have 3 weeks of float. And that float is shared amongst them. So it's not 3 weeks each, it's shared. So that's what we're trying to understand with a precedence diagram. So we can work that out analytically. So the way you do that is you put 0 for the first date, 0 plus 1. So it's going to start week 0, it's going to take a week, so that means it'll be finished by the start of week 1. So when can the next task start? The next task can kick off the beginning of week 1, the last 4 weeks, that's going to finish week 5. So we can work through till the point where we know that one activity is going to finish week 7 and the bottom activity is going to finish week 4. So when can that joining task kick off? Well, it can only start week 7. 7 plus 2 gives me 9, 9 plus 1 gives me 10, 10 plus 1 gives me 11. So that's what we worked out some time ago, that the total duration of this project is 11 weeks. And you can see that the longest path is the bottom path. So have you ever seen anyone plan backwards? They set the end date and then they work back. And that's called what we call a backwards pass. So the backwards pass, we take the 11 weeks and we put that as our end date, and then we work back. So we say, if I have to have my homework done by week 11 and it takes me a week to do it, when do I have to start it? Week 10. Which means the previous person has to finish week 10 and they have to start week 9. Which means the previous person has to finish week 9, so they have to start week 7. Which means that bottom person doesn't have to finish their work until week 7. They could have it done by week 4, but they must have it done by week 7. So the earliest they can finish it is week 4. The latest they must finish it is week 7. So the difference between those two numbers is what we call the total float. The amount that task can slip before it delays the total project. So there's another concept called free float. Free float looks at the following task. So how much can task 1.2.1 slip before it delays the next task? Why do we care? Well, this would matter if the person doing the next task has booked holiday and you can only have them week 2, or they've got another project to do. So if you miss the window, then you're going to have to wait 6 months for them to come back. So we need to understand what the free float is on that task. So 1.2.1 is due to finish week 2. And the person who's doing 1.2.2 has booked in week 2 to 4 to do the work. So that task has no free float. If you miss that window, you're going to have to, that following person is going to have to reschedule their work. Whereas 1.2.2 is going to finish week 4, then when's the next person need the information? Week 7. So that's got 3 weeks of free float. So you could slip back and you won't delay the following person. So free float really only matters when you've got a critical resource that cannot reschedule its work. Provided that resource is flexible, you can reschedule within the total float and you're not going to delay the project. But free float is dependent upon the resource availability of the next resource in the chain. So normally we take that information and we map it on a Gantt chart. So this is a Gantt chart here, and you can see the critical path is the path at the top, and you can see that there's float on the bottom path. And you can see there's 3 weeks, 3 bars of float shown on the bottom path. And usually most people are familiar with critical path Gantt charts like this, but they maybe don't realise that behind the Gantt chart is sitting that precedence diagram, and it's driven by that precedence diagram. So if I said to you, I want you to write a report, in your head you thought you could maybe get it done in 6 days. But you might say, well, actually, I need to build in a bit of contingency. So I'll say it's going to take 10 days or 12 days to do the report. And that gives you some contingency. So what we can do with critical chain, you can say, well, who should own that contingency? So that contingency should really not belong to the task person, the person doing the work. It should be shared across the project. So what we do with critical chain is we take all those contingencies out of the individual tasks and we share them in what we call a project buffer at the end of the project. So I might give you a 50-50 target date. So I might say, could you try and have it done day 6? But if it's late, don't worry, we'll absorb the delay in the project buffer. So critical chain also recognises that if you have 2 tasks in parallel and they're all using the same resource, then you can't do two things at once. So here's a critical path example with resource A, B, C and E, and the critical path is the longest path through the project. But what we haven't recognised here is that resource C is doing 16 days work on the top path and 16 days work on the bottom path. So it can't do two things at once. Well, it can try, but you can't do two things at once. So if you think about it, the critical chain goes through resource C. So it's got 16 days, then we've got resource C 16 days through resource O. So there's no precedence between resource C, the two resource C tasks, 4 and 5, but what there is a resource dependency. So with critical chain, we do those two things. We recognise that the most critical bit through the project is through the resources, and we also say, well, actually, let's take all the contingency out of the project buffers and put it in a project buffer at the end of the project. Now, if I've got a critical resource C, what I want to do is make sure that that resource C is never waiting for work, because that's my constraint on the project. So everything that feeds into resource C, I'll put a bit of a contingency on it. So I'm going to finish everything that they need a couple of days in advance, so that if there is some form of delay, that material is ready for them when they need it. So that's critical chain. It's quite useful for R&D type projects, which are very resource intensive, where you're using expert knowledge really, and where resources are the driver of the constraint. Where resources are more flexible, where you can hire additional resources in, sort of traditional trades, then critical chain is less useful. So it's in those highly resource constrained product development or R&D type projects, or maybe IT projects where you've got very limited ability to bring specialist resources in. So critical path focus on the logic. It allows for some form of contingencies. It doesn't recognise individuals as individuals. It treats people as resources. Critical chain is the dependencies depend upon the resources we use. It pulls the contingencies outside of individual tasks and shares them across the projects. We usually ask people for 3-point estimates, best, most likely, worst case, in order to produce that estimate, the best estimate, the duration. Software can be more difficult with critical chain, and usually we're aiming for an earlier finish. You know, we've got this relay runner work ethic within critical chain, which is targeting let's finish as fast as possible, really. Not finish by the target date, but finish your work as quickly as you can. So it's a significant difference in culture. So, well, what we've looked at is two approaches to developing a schedule for the project. One using critical path, which is more useful when you have flexibility over the resources, I expect, and it's simpler and easier to apply. And one using critical chain, where you are dependent on some key critical resources that form a constraint for the delivery of your project. And so you schedule all the work around those critical resources. So I hope you've enjoyed this section of the course.